Hello, everybody, and welcome back to Creation Myths. I have what I think is a fun and hopefully entertaining one for you tonight. This isn't something I do super frequently, but we're going to do a responding to critics tonight. Before we get there, I have a couple of housekeeping items to share with everybody that are also, I think, pretty exciting. So, the first thing is that next week, same time, same place, we're going to do another live show. Next week, it won't just be me, though. Tonight, I'm solo. Next week, I'm going to have a couple of guests. It's going to be Dr. Zach Hancock, friend of the channel, and in real life, Dr. Zach Hancock will be joining me. And up and coming YouTube sensation, Mr. Anderson will be joining us. And we, the three of us, are going to do a debate review of a conversation that Mr. Anderson had with Standing for Truth, Donny Deals himself, on the topic of genetic entropy. So I think that'll be really fun. I'm really looking forward to having that. We've been trying to get that one together for a while, and the planets have aligned, so we're doing that one next week right here. The second thing that I want to share is something that I cannot share entirely yet. I can't give you all the details yet, but what I can say is I have something extremely exciting that I will be able to share the details of soon. And as soon as I can share those details, you better believe you are going to hear about it. But I got very exciting news about that thing yesterday, and you all will hear about it as soon as I'm able to share fully. So that's just something to look forward to. You'll know it when you hear it. It is extremely excited. I'm pumped for it. You'll know when it gets here. So that all being said, get some housekeeping stuff out of the way. So let me just get my windows a little better organized here on screen, and then we will get to the actual show tonight. So let's do it. So what we are going to do here is a responding to critics. Yes, I'm sorry, in the chat I see SFT won't be here. Bummer. I don't know, maybe he will be. And if he shows up, then he'll be welcome to join and we can talk. So what we are doing tonight is a responding to critics. As I sit here live recording this on March 6th, 2024, my most recent recorded video that I've released is a creation myth that pedigree mutation rates somehow provide evidence for or prove a recent creation for humanity, right? It's the take the pedigree mutation rate, count backwards, you get 6,000 years thing. That's the topic of my most recent video as of right here. So since that video went live, Standing for Truth and RawMatt took issue with that and responded in as part of a very long 4-hour live stream a few days later. And that's what we're going to be reviewing and responding to right here. Now, first things first, my original video, the creation myth on pedigree mutation rates, that explains why you can't just extrapolate those rates backwards to get your time to most recent common ancestor. That video is linked down below. And if you're watching this after the broadcast, if you're here live, hi, stick around, this will be fun. If you're watching this after the live broadcast, and you haven't watched that video, go watch that video first. Things are going to make a lot more sense if you watch that one first, then come back and watch this, and we'll see what the issues are and what the responses are. So I'm just going to briefly review that video that I put out last week, and then we'll get into the really good stuff with the response and how we can respond to those arguments. So in this video on pedigree mutation rates, I focused on basically 8 things that are wrong with this argument that creationists make. And I basically said, here are 7 things that we're not really going to worry about. And then here's a big one, number 8, that we're going to focus on. So those 8 things, very broadly and very quickly, are misunderstanding just like the concept of what a most recent common ancestor is, ignoring more distant most recent common ancestors that you get from looking at autosomes rather than the Y chromosome or the mitochondrial DNA, conflating mutation and substitution rates, which is a favorite thing that creationists do, ignoring direct documented confirmation of slower mutation accumulation rates, including in their calculations somatic mutation rates, which never get passed on, but including them anyway in that per generation rate, ignoring the distinction between coding and non-coding mitochondrial DNA, which accumulate mutations at different rates, and then just doing like the math incorrectly. But then the big one that I really focused on in that video was how creationists cherry pick their studies. They'll focus on just a handful of pedigree studies and ignore mostly multi-generational or deep pedigrees that contradict their desired results. And when you include all of the pedigree rates, turns out you get like the conventional biology answer. You get the accurate answer for the time to most recent common ancestor for the mitochondrial DNA and the Y chromosome. So as we go through this video from Donny and Matt, I want everybody watching to just, periodically check in and ask yourself, how many of those 8 objections are Donny and Matt even trying to address? How many are they actually saying, okay, this is the critique, here is the response to that critique that explains why it is invalid? Now, they should have had time for all of them, considering that it was a 4-hour stream. The first hour was wasted because Kent Hovind was on, so that's just like, that's pointless. But then the other 3 hours, they talked about my stuff a little bit. They talked about like transitional fossils for a while in there. And as you may or may not know, they tend to meander and get off topic. So out of that 4 hours, something around an hour was theoretically responding to my video, but we're boiling it down to like less than half of that. We're going to just cover about 20 something minutes broken up into little chunks because they just meander and get off topic. So Donny and Matt, if and when you watch this, this is how you do a response to somebody else's video. You have the video ready, you have specific time points that you want to go to, and then you respond to those time points without getting distracted, and then you move on to the next one. You don't keep spinning off in all different directions, so you have to go through like 3 hours to cover half of what you wanted to cover. And I have to assume they only covered half of what they wanted to cover because, as you'll see, they don't actually address very much of the video that I put out last week. So let's get right into it. I'm going to pull up this video here for us, and in the chat, just let me know if the video and the sound works okay. I set the levels good for me, but if it's too loud or too quiet, let me know and I can adjust it. So I'm just going to start this and just jump to a spot, and then I'll jump to the spot where I want to go once we're good to go.
Started off no bigger
Okay,
than
so let's see here.
This is real stupid, and I resent them calling.
So we're going to jump to 1 hour 8 minutes in. So we don't need to hear Kent. That's a waste of time. We're going to jump. I mean, it's all a waste of time, but we're going to do it anyway. So we're going to jump to 1 hour 8 or so right here. Okay, that's close enough. And we're going to let this play for a little bit. Stay here quiet. All right, we'll turn that up a little bit.
Come up with a mutation rate. Typically,
so we're going to let this play for a little bit. And then I have to be able to hear
grandmother, grandmother, mother, daughter.
And we'll be good here.
And come up with a rate that's quite fast as well. But he's saying...
Okay. So a little quiet. Here we go. Let's turn that up a little bit more. Here we go. Okay. So I'm going to let this play for about a minute, minute and a half, and then we'll talk about it. So let's jump right into it here.
The deeper you go in terms of your pedigree rates, the rate goes from fast to slow, a lot slower than what we observe. And so they would then argue that mitochondrial Eve goes back a couple 100,000 years.
I already have to pause because he said when you do a deeper pedigree rate, the rate goes from fast to slow, much slower than we observe. It's a multi-generational pedigree. That's still a direct observation, right? We still observe that, right? So right away, like, remember what I said was one of the big problems here was cherry picking studies. Right away, we're just doing the thing, right? We're just right away cherry picking the studies.
Rather than just 6,000 years as we would purport based on the biblical model of ancestry. What are your thoughts, brother? Go ahead.
Well, one, I would say that you're going to get a lot of different results all over the place on different pedigree studies simply because of the fact that different people groups mutate at different speeds. Take, for instance, the Amish families, right? They have generation times up to 30s and 40s. They basically bear children until they can no longer do it anymore, right? So you're going to get slower mutation rates from them as a people group, and we do see that. So you're going to get some. But if we actually look at a chart.
Just a quick note here. I'm not going to dwell on this, but it's one of RawMatt's favorite things is that like different people groups have different inherent mutation rates, and that doesn't, we don't have direct evidence of that. Just FYI, Matt.
That I was able to put together. I didn't finish this in time. Obviously, I didn't get the generational links on this one, but we find almost the exact same results as every other substitution and pedigree rate study that there is anyway. I grabbed, Dan did one by adding another one last night, and that has an 11 generation link, which is much more than Parsons at just 2 and 3. And look, the results were basically exactly the same. 9 mutations out of 345 family links that they tested. It's right on par with all the other pedigree mutation rates, and they never ever reach the evolutionary timeline. That's what we're trying to show.
Okay, so let's just pause right here for a second, because Matt is making a very basic error here. So what he's doing in this table is comparing apples and oranges in a very obvious way. For example, that Parsons study that he loves to lean on, which is right here, the 1997, some of these other ones, these are studies of a region of the mitochondrial DNA called the D loop, which contains regions called the hypervariable regions. They mutate faster than the rest of the mitochondrial DNA, or I should say they accumulate mutations faster than the rest of the mitochondrial DNA. Other studies that he cites here, like Connell et al., 2022, that is a whole genome study. It's looking at a mutation rate across the whole genome. So you can't compare those two things without adjusting one of them to either scale it up or down, right? Otherwise, you're comparing numbers that are not comparable to each other. And the reason you get a fast rate of accumulation for things like the Parsons study is because it's one generation out, however many generations in the D loop, like 1 out of 33 in that specific D loop region, which is a smaller number of base pairs rather than the whole genome. It's just a small fraction of the mitochondrial genome. Okay, that's what's going on here. So if you take the rates for the whole genome, as I showed in my original video, it's way outside the young Earth timeline. And that's what's going on with Connell et al. 2022 and some other studies that aren't even on the table that he's just leaving out. Because again, the big thing that they like to do is cherry pick and just leave out studies that disagree. Okay. So the thing that, like I said, the thing that they're theoretically responding to, that the big problem that creationists have is cherry picking, they're doing the thing. They're just doing the thing right here that I pointed out. This is exactly what I'm talking about when I'm criticizing them. They're doing the exact thing I'm criticizing them for in their response, attempting to refute my critique. So that's where we're at.
We're not trying to make a date land and prove, look, this exactly proves Eve lived it exactly then, ignore every other study. No, our goal in Young Earth Creation is to present to you evidence that best explains the diversity in the world that we see today. It's what any model of evolution would try to do. Our goal is to say, well, what best explains the diversity of life in animals and in human beings? And evolution says, well,
now, he's going to be very honest about his goal in just a little bit later in this video. I'll point it out when we get there because it's one of the most honest things Matt has ever said on air. We'll get there. Don't worry.
We want to use the evolutionary idea and look at only phylogeny. And then when we look at the observable rates, they point to a better our timeline. Do all of them? No, because there's lots of factors that come into it. And you also got to remember that different people groups have different substitutions arising and reaching fixation based on the population. So
there's a whole lot of problems here. First, different people groups, again, not a real thing. Like, it's just not a real concept. It's not a real thing that exists. Okay, not a real thing. Second, he's saying substitution rates in different lineages. I don't know if he doesn't understand what like a substitution is. Actually, I know he doesn't based on something we'll see later in the video, but he's using the term incorrectly here. And we'll see. There's a problem with understanding terminology here on the part of RawMatt. And then again, I just need to point out when he says we creationists look at observable rates. Well, you're not. You have Connell 2022 there, but you're actually misrepresenting it, saying it gets you a young Earth date for the most recent common ancestor. It doesn't. I did the math on that one myself. He's also leaving out the Tristan da Cunha study from 1998. He's leaving out the King 2014 study. That's the King Richard III one. In addition to some other studies that I mentioned in my video. He's just leaving them out. So again, we have this thing where they're saying, we have the observable rates on our side. No, you don't. You are cherry picking. You are doing in the response video to my video the exact thing that I pointed out in my original critique. So that's where we're at. So now we're going to jump a little bit because, like I said, they get off topic really fast here and they go down rabbit holes. So now we're going to jump just a little bit. We're going to jump up to about 112 and change here. That'll do. We're going to jump to right here and we'll play this for just about like a minute and change here.
So what would you say to Mr. Anderson? He just asked, here we go. Matt, are you saying that I'm wrong? This is Mr. Anderson, about the rate slowing down as roots go deeper.
Well, I just showed you multiple studies that got the deeper roots that got the exact same results. So I'm sure you found some studies that might have gotten slower results, but I said there's always reasons. Did they look at only hypervariable region 2? Did they test only inbred people? Did they test people?
Okay, so first, RawMatt just made an argument against his position without realizing it. The studies that only look at the hypervariable region get a faster per generation mutation rate. And the reason for that is what happens is they take the rate in the hypervariable region and they kind of extrapolate that. The hypervariable region is called hypervariable because it accumulates mutations faster than the rest of the mitochondrial DNA. When you look at the full genome, the rest of the mitochondrial genome accumulates mutations at a slower rate than the hypervariable region. One reason the older studies, notice a lot of these studies are from like the 90s, is because we weren't doing a lot of sequencing back then, right? We just weren't sequencing huge swaths of DNA. This is before like the entire human genome was even sequenced. It was expensive, it was slow, and you want to find differences, you look in the hypervariable region. So that's what these older studies from the 90s did. It's no coincidence that we get more full genome studies as we get closer to the present, as sequencing technology gets cheaper and faster. Okay, so what RawMatt just did there by citing hypervariable regions actually hurts his case, even though he doesn't understand that, I think. That's still what's going on.
People that live on islands and are only isolated. There's so many factors. That's why the studies are all over the place. That's why you want to look at multiple studies and don't just look at one. Don't just look at like, oh, well, this study over here got the results that I like and it really slowed it down. Or I only looked at the Amish people and that date didn't add up to young Earth creation. Well, we have population groups everywhere. That's why you look at all the studies. And the more you look at, the more congruency you find. And guess what? We are the ones making predictions. Where are your...
This is good. We're going to get there. I just want to point out just briefly here that, again, even on the table he's showing on screen, he's leaving out a whole bunch of studies. Like, he's just lying. Like, I don't know how else to say it, everybody. Like, he's just not telling the truth. He's saying, we include all the studies. They all show the same thing. He's leaving out a bunch of studies in the table that he's showing on screen. And also, there are studies, the studies that he's showing on screen don't show the thing that he says they show. All right. Like, I don't know how to say it more clearly than that. It's just that simple.
Predictions on this. They don't come from the evolutionary side. They come from our side. And that's why nobody does any head-to-head predictions against Nathaniel Jensen making testable predictions about this. You can go ahead and test Nathaniel Jensen and go ahead. Take his challenge. I dare you.
So has anybody know if anybody has directly tested Jensen's predictions on mitochondrial mutation rates and the rates of mutation accumulation in mitochondrial DNA? Anybody know of anybody who did a video on that a couple years ago, directly testing Jensen's predictions? Oh, I know. I did that. I did that exact thing. I actually took Jensen's rates and tested them against populations where we know which two groups diverge from each other and when they diverge from each other, and we have their mitochondrial DNA sequences, and we know exactly how many differences have accumulated in those two lineages since they diverged. I actually directly tested that. And I went and looked up the numbers before this just to make sure I had the numbers in front of me. So what happened with those predictions is that Jensen's predictions were off by a factor of 5. That's 5 times, not like 5 mutations per whatever unit of time, 5 times, a factor of 5. And that's only if you use extremely generous assumptions like a 15-year average generation time. If you use more realistic parameters like a 20 or 30-year generation time, Jensen's error goes up to a factor of 60. He was off by 60 times based on his maximum rate of mutation accumulation and the known time that those two populations were separate. So yes, Matt, I've done the exact thing you're asking for. I have directly tested Jensen's predictions, and it turns out that the evolutionary predictions are spot on, and Jensen's are off by approximately an order of magnitude. But I guess you're not super familiar with, the work that's been done here over the course of this conversation, but that's okay. So we're going to jump ahead a little bit here. As we do, we're going to jump a little bit further because they kind of like spin off on all these different tangents. So we're going to hop just another minute or two here. That'll do. And we'll pick this up for a little bit. And then we'll continue onwards. Let's listen.
Getting off of Noah's Ark, they're coming down about 7 or 8 generations later. They reach, everybody converges into Babel, and then they lose their languages, and then they disperse, and they leave in small groups around the world. So these mutations that have been rising up through all these generations finally start to form in all these different people groups as they now migrate out to the world that they've inherited, the different lands, Ham, Shem, and Japheth. And these families now start to branch out, and they start to diversify, and they grow in population size, and new mutations are now reaching fixation based on the population size. So if you get down into South Africa,
I just want to point out a contradiction here. It's not the first time I will point this out in this video, but he's saying the fixation rate is based on the population size, which he's not wrong, right? The effective population size does affect the fixation rate. The problem is he wants to say the fixation rate is equal to the baseline mutation rate, which is not a function of population size. Can't be both things. He can invoke population dynamics when he wants, and then in other times say that the fixation rate equals the mutation rate. Can't be both things, but he doesn't know that. But those two things are impossible to be at the same time.
Where there's no farming and agriculture, and they live in small tribes, what are you going to expect to find? More fixed substitutions. So they're going to look like older people groups. Guess what we see? Africans look older, but they're not. Are Amish older than other Europeans? Of course not, but they mutate slower. So there's always reasons that there's differences in these mutation rates.
I just want to point out that basically none of what he just said is correct. Just want to point that out.
So when you say a fixed substitution, just for the audience sake who might be confused by that, is a substitution a type of mutation that can occur?
Yes, a mutation and substitution, essentially the same thing. The mutation rate and substitution rate are basically the same thing. They're a new substitution, they're a new mutation arising in the genome, and then as they arise, based on how fast they reach fixation until everybody in that population has it, that is more based on the population size. And so a lot of these studies, they will take into account what was the population, and then how long would it take for a mutation to drift into the population and size until everyone has it. And it also explains why certain people groups have one fixed mutation, as take from Neanderthal.
Okay. We don't need to hear about Neanderthals. I know that was painful for some of you to listen to. It also caused me physical pain. So first things first, just a very simple thing. He's talking about fixation, but he's also talking about pedigrees, which are familial relationships. You're looking at individuals. Fixation refers to a mutation achieving a frequency of 1 in a population. Pedigrees are not appropriate tools to study fixation, right? They are not the same thing. I don't know why they can't separate this out. I think what they're doing is the Jensen thing, because I mean Jensen does this, and you know, Donny and RawMatt don't know what they're talking about, but like Jensen has no excuses, and then this is what happens. The YouTube amateurs like hear Jensen and then they kind of parrot it, but it goes through this game of telephone and it comes out as the gibberish that we just heard. The other thing that I think is happening here is that the authors of these papers are using the term substitution in a less formal way as basically synonymous with mutation, right? They mean one base is substituted for another base in the mitochondrial DNA, okay? That's a different usage of the word from the technical sense of a mutation achieves a frequency of 1. What Matt is doing is taking that informal use of the word, which is extremely clear that that's what they're doing from the context. They're using it in an informal way. And he is interpreting it, knowingly or not, I suspect not, as the formal population genetics usage of the term substitution. And then just one last little thing here. The quote was, a mutation and substitution are basically the same thing. I have nothing to add to that. I can't comment further. Just real experts here. I got nothing on that one. So I'm going to jump ahead to a very short little bit. It's very important in terms of context for this whole thing. So let's just jump down to, yeah, right about here. Here we go. Let's listen to this real quick, everybody.
Exist in different groups of people worldwide.
Right, exactly. That's because of our model. We have to explain our model. We're not just attacking evolution. We're explaining the diversity that we see in human beings today based on our model, based on the timeline that we get from scripture. That's what we're doing. We're using the mutation rate. We're looking at substitutions and how they reach fixation. That's our goal from this. So
there it is, folks. He accidentally spoke the truth. That is the most honest thing I have ever heard RawMatt say on air. We're basing our model on the timeline we get from scripture and using rates that we can use to match that timeline. Yes, that is what you're doing. Thank you. That is what I was pointing out that you were doing in the video that you're theoretically responding to. You just admitted the thing that I said you were doing. Thank you. I appreciate your candor, RawMatt. Thank you for doing that. That's it. That was a tiny little section. So now we're going to jump up another little bit here. Yes, this is a good section. Talk about a very common thing that is very frustrating to hear all the time. Here we go. All right.
Go back in time past them and go to Eve herself. But we can't do that with Noah and the lineage of the Y chromosome because there was only one Y chromosome on the ark, which was Noah.
Right. Here we go.
So we can't go back to Adam. We can only go to Noah himself.
So I just tracked down Dan's video here. There's a couple points from it that I want to address. But here he responds to one of your comments. And I'm wondering if he misrepresented it or what you think of it, Matt, my brother. So he's saying based on these studies, specifically the Parsons rate, because we understand the mutation rate in the Parsons paper was very fast, takes us to a mitochondrial eve of just 6,000 years. That's the observed mutation rate. And this methodology was adopted, if I'm not mistaken, by the FBI. So obviously it's very reliable. But
okay, you hear this all the time, and this might even have to be like a creation myth video of its own at some point. But the stupid thing with the FBI, what's going on here is this. So the FBI, they use the rate of change that the Parsons paper, again, from like 1998, I think it was, they use that. I don't know if they still use it because there's like been a lot, like there's been new stuff since then. But they used to at least use this rate kind of in their forensics. And what Donny and Matt, what they love to do is they take that rate and say, well, the FBI uses it. Obviously, it's accurate, so we can use it for long-term things. The question I have is, do you think the FBI is doing coalescence analysis here? Are they calculating time to most recent common ancestors with like blood samples from crime scenes? Obviously not. What the FBI is doing is they're taking that rate and they're saying, okay, if we get a sample forensically, and we can get a sample from like a suspect, the family of either a suspect or a victim, right? A parent, a sibling, a cousin, whatever. We can say how many generations removed is that person we got the sample from the suspected blood sample or whatever from the crime scene. How many differences do we expect if they are actually related by X number of generational links, right? If it's a parent, if it's a cousin, you know, how many differences do we expect? That's why the FBI can use that rate, right? It's a forensics tool. They're not doing the type of population genetics. They're not doing the calculations to calculate like the overall, you know, mitochondrial time to most recent common ancestor, right? The FBI doesn't care about that. What they care about is if you get a blood sample at a crime scene and we get a relative of, you know, a potential suspect, right? And they give us a sample, how many differences can we expect in order to rule out, right? How many differences would be so many that we'd have to rule out that relative as the source of the forensic sample? That's how the FBI uses this stuff, right? It's not doing the thing that we're talking about here. It's a complete just red herring. It's irrelevant to this conversation. But Donnie loves to bring it up. So this next segment here, I'm just going to let this play for a little bit. And I'm going to apologize ahead of time because it's I don't know what to make of it. So I'm just going to let it play and you all can tell me what to make of it. I don't know. I also see Carrie Bronson. I can't pull it up on screen because StreamYard's being weird, but I see Carrie Bronson as a $5 super chat. They say, even in lieu of a drinking game, you need to establish a meme donation. Such things always end up drawing more donations. It's a good point. Maybe I'll have like an SFT bingo card or something. We'll figure something out. Thank you for that suggestion, and thank you for your generosity. I appreciate that. So I'm going to let this play, and what I want to ask in the chat, and everybody watching this live, can you make sense of this next segment I'm going to play? Because I will tell you, I cannot.
He's saying if you take this rate and do the math correctly, you get an eve of 39,600 years. What are your thoughts on that, Matt?
Okay, well, he was good. Again, he's looking at it like a direct line lineage of only happening in a single population over and over. So remember, we're talking about populations diverging from one another. So now that same mutation is another mutation is popping up in a different group of people that's now rising to fixation over there. And it's also happening in this population arising over there. So if it was a single population increase from that people group, sure, you can count them up in a linear progression, but that's not what we see. We see people groups diverging because of language breaking apart at Babel, and then people groups leaving in 3 separate groups of people going to their different lands. So now you can take that 33 generations and put it in that population, and then put it in that population, and then put it in that population. And that's how we would get there. And
I have no idea what argument he's trying to make there. I don't know if he knows what argument he's trying to make there. But I don't know what he's trying to say. I legit do not know. If anybody could parse that, be my guest. But I don't know what he's going for. Yeah, I just wanted to play that because that's representative of a lot of the stuff I'm skipping. It's just this gibberish, this like Mad Libs of stuff that Donny and Matt think sounds smart and makes no sense. So if anybody can parse that one in the chat, feel free. Try to explain that. Make sense of that little clip for me. Because I can't. I tried. I don't know. So we're going to jump down to the next section here. Let's go down to just another minute or two in the future here. We'll start there. That's fine. We'll pick this up in about 15 seconds is where it starts getting relevant.
The different people to make sure that we're not messing this up with just some mutation rate. We want to make sure that it's an actual rate that's shared among other people, right? So we do see that. And then what else do we see? Oh, I'm sorry, I'm dragging them into the wrong spot.
Here we go. Let's see what he says.
We read, this is the mutation rate. This is the substitution rate. He breaks down the math on what they expected to see, 1 mutation every 600 generation. They did not find that, which they were expecting to find mitochondrial Eve about 133 plus thousand years ago. They found that the clock in most recent common ancestor 6,500 years ago. But the evolutionists always say, well, that's just the most recent common ancestor. That's not the first one. That's not Eve. Okay, well, when in the evolutionary timeline and model could the human population have bottlenecked down 6,500 years ago to make every human being on Earth go only back 6,500 years ago? I mean, come on, that doesn't even make sense. The world is completely...
Okay, so think back to what I started with, and if you watch the video that they're responding to, think back to that. Because one of the things that I called out in that video was that when creationists do this kind of analysis, let's call it, they misunderstand what a most recent common ancestor is. And RawMatt in particular seems to think in order to have a most recent common ancestor, you need to have a bottleneck. Now, a bottleneck is when you have a population that's quite large, and then it rapidly shrinks back down, and then it expands after that rapid decline. Okay, that's a population bottleneck, and that has large effects on the population genetics because it shrinks the effective population size. Okay, that's what's going on here. That's what he's saying is indicated by the time to most recent common ancestor. That's just a misunderstanding of what most recent common ancestors are. Most recent common ancestors are going to occur, just like mathematically, through regular old mundane population genetics processes. You don't need a bottleneck to have a most recent common ancestor, but RawMatt seems to think that most recent common ancestor is synonymous with bottleneck. And I didn't put that specific thing on my misunderstanding most recent common ancestor slide, just to save space. I didn't put it on there, but like, that's what he's doing. He's doing the thing I pointed out, just not understanding how most recent common ancestors work. Okay, so let us continue because he's going to dig in his heels right here.
Populated, even Americas with the Indians are already populated in the evolutionary timeline. The only timeline this makes sense in is ours. That's the only one. So look, they even acknowledge that the most recent common ancestor of mitochondria, Eve, may have been younger than the most recent common ancestor of modern humans. That's what they're trying to say.
He's this close to accidentally understanding it. I'm going to read that part from the transcript again, right? They even acknowledge that the most recent common ancestor of mitochondria may have been younger than the most recent common ancestor of modern humans. Yes, exactly. Because most recent common ancestors are not the origin of the species. And they're not the only individual alive at the time. He's so close. He was accidentally said something that is correct. And then it's just like, that's dumb. Those stupid evolutionists. But like, he actually said that sentence actually correctly articulates what's going on here. And it's not like this is some far-fetched thing. This is a mathematical necessity, right? And you could even just, because we're talking about mitochondria here, it's really simple without getting into any population genetics at all in terms of mutation rates and substitution rates. It's even simpler than that for mitochondria because the effective population size of the mitochondrial DNA is smaller than the effective population size for like the human nuclear genome, the autosome. So he's brushing up against one of those things that I pointed out in my other video without realizing it. So because the effective population size is smaller, right, the mitochondria converge at a more recent point in the past, but the rest of that genome doesn't, right? Mitochondrial Eve, right, she's represents the most recent common ancestor for the mitochondrial DNA, but not for the rest of the genome. That stuff converges in the more distant past. Like, this is super basic, and I cannot believe that, like, I'm always shocked at how wrong they manage to be. And every time I think I'm like prepared, he pulls out something like this, where he says something that's like completely mundane, like in this scoffing, like, oh, those stupid scientists, how could they think something so outlandish? When it's just like the most mundane observation that you could imagine. At some point, I should stop being surprised by those things, but I'm like a little bit reassured that I'm not so cynical that I've reached that point yet. Like that's a little bit reassuring to me. And I realize that, it's RawMatt saying these things, but we've got Donny like sitting there nodding along too. And he's not like pushing back or correcting or even like gently kind of nudging RawMatt in the right direction. Does he know better? And he's just dishonestly going along with it? Or is he in the same boat, just like completely ignorant of like the to borrow a phrase, breathtaking inanity of what RawMatt just said? I don't know what the answer is. I kind of go back and forth. I genuinely am not sure. But shocking that we're going to say something that's just blindingly obvious and pretend like it's some crazy thing. Let's continue. Let's jump up just a little bit here. There, that'll do.
Agree with Dr. Dan Stern Cardinal and Mr. Anderson. God bless you. We love you. Or Parsons himself, who we emailed, and
that was the sentence got cut off there. It was, do we agree with Dr. Dan Stern Cardinal and blah, 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 blah.
He gave us a great response to the critics. And Ann Gibbons, who has provided us a great layperson commentary on the Parsons paper.
Exactly. I mean, matter of fact, we even have this one. How about Caliver, who also does pedigree mutation rate? Remember his answer right here? No one thinks that this is the case. See, right here, about 6,000 years ago, no one, the evolutionary community says that. We don't think this is the case. But at what point should our models switch from one mtDNA time zone to another? I'm worried.
Notice how he just cuts off the rest of the phrase. He just cuts off the whole rest of the phrase right there. He doesn't like, he just says, I'm worried, period. That's not the end of it. And actually, I believe that's from the Ann Gibbons paper, which I am going to pull up right now. And let's read the rest of that sentence. I didn't plan to do this. This is a little bit just, off the cuff here, but let me just pull that up real fast here. Here we go. The whole sentence reads, I'm worried that people who are looking at very recent events, such as the peopling of Europe, are ignoring this problem. Says Laurent X. Coffier, a population geneticist at the University of Geneva. Right? It's not, I'm worried. It's, I'm worried people are ignoring the complexities here, is what that sentence says. So, just for a little bit of good measure, we just have just straight up quote mining there to make it look like somebody is saying something, and they couldn't even get her name right. Cavalier, it's Laurent X. Coffier is they couldn't even get the person right there. But anyway, always disappointed. Anytime a creationist uses a quote, double check that quote. There's like a 99% chance that it's going to be a dishonest quote mine, especially when it starts the quotation and then there's no ending quotation mark. Then then it rounds to 100%. Okay, that is like just there you go. So predictable, RawMatt. So predictable. So dishonest. Let's continue.
Why would they be worried? If this is nothing to worry about, if this is just some math problem they can fix, just throw in more pedigrees or they counted substitutions. They don't know what they're doing.
Exactly. Where's this 39? Where's this 39,600 years that Dan's talking about? Where was that Ann Gibbons, her commentary on?
That was actually Parsons who said,
no, the 39,000 years was math I did. They don't even, do they even watch my video? Like that was my calculation that I did. I didn't get that from somewhere. I took numbers from papers and then did the calculations the way creationists do them. They don't even understand the things, not just that I did. They apparently don't understand what the creationists did because I did it the way creationists do it. So if they're like, oh, where did Dan get those numbers? I calculated them myself based on the methods that you two gentlemen are citing. So like, what's the misunderstanding here?
The most recent common ancestor should be 133,000 years ago. But and Ann Gibbons reported that. This is Ann Gibbons' comment that she made, by the way, saying that mitochondrial age should be much longer ago, and we should find that in the genome. But we don't. We don't find that in the DNA compartments. They tried to slow the rate down by saying, we need to take into.
So you will notice that this is like a giant Frankenstein of a quote here. There's ellipses, there's parts of sentences, and then the second part, right, you'll notice here it's open quote and then close quote halfway, and there's another close quote at the end. So I don't know like what's going on with this Frankenstein quote here, but this is not what's going on with the Ann Gibbons paper that they're pulling from, which by the way was from like 1998 again. Well, that's another whole thing. But like they're either lying about the Ann Gibbons paper or they haven't fully read it. They just went and pulled a couple of juicy quotes and then stopped reading, because Ann Gibbons, that author, is like squarely in the mainstream camp that when you do these calculations, you get a date in the 1 to 200,000 year range. Like this paper is not ambiguous about that. That is the actual date. And in the second half of the paper, the author, Ann Gibbons, goes on to describe other studies, some of which I cite in my video, that get you the more distant time to most recent common ancestor. Pedigree studies, right? So she talks about a couple specific pedigree studies, for example, Tristan da Cunha, which was settled in, I think, 1816. And we could trace that was an uninhabited island when it was settled, right? So it's been, about 200 years. You can trace that back to the founding event, do the same math, and you get a date that's in the, the mainstream evolutionary timeline. But they just leave out all that stuff and make it seem like Ann Gibbons is in the young Earth camp. It's just dishonest. Frankly, they're just misrepresenting the whole point of that paper. The point of the paper is saying, hey, we got these weird things. Let's reconcile that with these other studies that don't show it. And there's one particularly striking paragraph in there where Ann Gibbons describes other people reading the Parsons, I think it was the Parsons paper they're referring to. They go back to their own data and say, okay, let's get more data. Let's reanalyze this. Let's see if we can find, more mutations in there. Maybe we're missing something. And they go back and the answer is no. And it's still the slower rate of accumulation. Okay, so that's the Ann Gibbons stuff. Let us continue. We just have a little bit more in here and then we'll jump again.
Consideration heteroplasmy, because there's a possibility that there's different forms of mitochondria in people that we need to account for. So they did it and it sped the rate up by 4. So it made it worse. Yeah. So they can't do that. So that's why Dr. Dan and other people say, well, maybe they're counting somatic mutations. And well, bad news, because in 2000, they decided, let's check Parsons right here.
Okay. Oh dear. Okay, so now we're talking about somatic mutations. The first thing I want to point out here is with Parsons. Parsons that they keep studying, they love Parsons. Their favorite paper here. It's 1998. Over 25 years ago. They're obsessed with these old papers from before we even sequenced the human genome. They're using these old studies to show this. Remember, the big error that I focused on in my video, the video that they're supposedly responding to, is that they're cherry picking, right? They're picking a couple of papers and ignoring other ones that contradict their desired conclusion. It's exactly what we're doing here. It's like, they're just doing the thing that I said they were doing. They're not refuting what I said in any way. They're actually giving me more ammunition. They're giving us another example of them doing this exact thing. There have been a lot of studies. I cite a bunch of them in my other video since then that contradict that. Some of them from the 90s, some of them, more recently, 2022, for example. But here we are, just Parsons. And then, of course, the somatic mutations problem, which is that if you look at 2 generations, right, parent and offspring, you're going to look at all the variation in the parent. You're going to look at all the variation in the offspring. Some of that's going to be in cells that are not in the germline. So you're overestimating the degree of differences that are going to go from one generation to the next, right? The maximum rate at which mutations could accumulate. If you're counting a bunch of somatic mutations, they can't transmit, right? Whatever tissue samples you take, unless it's germline, there could be mutations in there that are not transmissible vertically to the next generation from parent to offspring. But like these studies that only look at one generation, that's what they sweep in. And like the Ding study from 2015 that Dr. Nathaniel Jeanson leans on for his Answers in Genesis blog post on this, that study, like me and David Neff reached out to the authors of that study and said, hey, did you filter out somatic mutations? The authors were like, no, we didn't filter them out. Okay, then everything is wrong. Like you can't use those over the long term. It's not that hard. But here we are just... Again, I shouldn't be surprised, but I am. So now they go off onto different topics for like for a while. So now we're going to jump a bit here. So let's see, where are we here? We're going to jump to 151. We're going to jump up here now. Yeah, that'll do. We can even go a little further than that. 150. Here we go. Yeah, that's good. All right. So we have just a short little segment right here. This is, I think, instructive in terms of a very common approach that creationists use to this conversation.
Any two people. Okay. And about 25. If you were to look at the Eve consensus sequence paper that I talk about frequently, you have on average about 25 DNA differences separating any person from the Eve consensus sequence. And so we're not necessarily concerned with species-wide change. Okay. We're concerned with divergence from the Eve consensus sequence. How long does it take to accumulate an average of 25 DNA differences and a max of 140? And it doesn't take long at all.
Okay. So let's talk about this. What Donny is doing here is an example of what I like to call being stupid on purpose. He does this all the time, bringing up the average differences between, you take any two random people on Earth. On average, the differences in their mitochondrial DNA, it's going to be about 20 to 25 differences. Like that's like the average. Okay. He knows that to calculate the time to most recent common ancestor, you have to consider the maximum amount of divergence. Since according to him, they started at the same sequence in the past. So if you have the same person in the past and you measure an average of 25 differences between any random people, that doesn't help you get back. That rate of accumulation doesn't get you back to that common ancestor if the maximum difference is, it's about 120. It's about 120 differences. He says 140, whatever. It's over 100. Doesn't matter what the number is. It's more than 25. And you have to account for that maximum amount of divergence, right? Your math must accommodate that level, not just the average. I have no idea why he brings up the average. Maybe it's to trip up people who don't know better because it's a, dishonest debate tactic. I don't know. It's an important distinction, right? The average versus the max. And I hope he knows better. I think he does know better. But that would mean he's keeps dishonestly referring to this average as though it matters, even though I if I'm being honest, I think he knows better. Does that mean that I'm calling him a dishonest hack for saying something that he knows is not a valid argument, but making that argument anyway? Yeah, that's pretty much what it means. Sorry, Donnie. Prove me wrong. I got another super chat here from Carrie Bronson. Thank you. I appreciate how your entire circle basically agreed to the name Answers Research Blog, ARB, if you will. Yeah, the Answers Research Journal is not a real journal. It doesn't engage in real peer review. It has a statement of faith that you must adhere to in order to publish. So it's not in any sense a journal. It is what it is a blog. Right, it's the Answers in Genesis blog, and their blog posts are formatted like scientific papers. They're LARPing doing scientific peer review, but they're not. It's a blog, and I love that. I'm going to use the name Answers Research Blog from now on, and I'm going to suggest everybody else does too. Answers Research Blog. That's what we're doing. Okay, let us jump down just a little bit here. We have one more little segment here and then another big jump in the video. We're not going to like go through this. I know we've been going for almost an hour. We're not going to go through this at a snail's pace. We're going to make some huge jumps after this little segment that we're going to cover right here. So we're going to jump up to just a couple minutes here. We're going to go to right about there. That'll be good enough. Okay, let's do it. I just want to say they did show a few minutes of my video before this part that we're about to do. They showed a couple of minutes kind of leading into this, but we don't need to watch my video. I got another super chat here from Bread of Life. Thank you. I appreciate it. I may have missed this because I stepped away for a bit, but what is the measured mutation rate for mitochondrial DNA in the recent past? So it depends on how recent you're looking at, basically. One generation, it can be quite rapid if you, like, especially if you don't filter out somatic mutations. You're looking at a rate that works out to approximately one mutation every 6 generations. If you go back a little bit further in time, you go back 100 years, 200 years, 400 years, with known pedigrees and known number of generations, you get a rate that works out to 1 every 30-something generations or more. There's one study that if you're careful to filter out what are potentially somatic mutations, you get a rate that's like 1 every 172 generations, I think it is. So it varies a lot depending on the time window. Yeah, so the longer windows get a slower rate typically. We have a super chat, $5 from Savage Premarital Mitosis. And again, I messed up StreamYard somehow and I can't put them on screen. I don't know why. They're not popping up on StreamYard, so I apologize, but I'll just read it out loud here and everybody can see it in the chat. A blog becomes a journal when you add a fake watermark, right? Yes, totally. Okay, let us continue here. So I'm going to play this. Again, they played a little bit of my video here, but we're going to skip that. We're not going to worry about it. Right here with the dots, the bottom row represents the present, the top row represents the distant past, and the colors represent ancestry. So all the blue dots share an ancestry. They're also playing my video faster, apparently.
Okay, so Matt, if I'm understanding correctly, and I'm curious as to your thoughts, Dan is trying to say that just because we have one female mitochondrial DNA ancestor of all people on the planet doesn't mean that woman did not exist in a greater population. As in, most recent common ancestor does not equate biblical Eve.
Yes, exactly. Yes, that's like a very basic principle in population genetics. Yes, thank you for articulating that.
What are your thoughts, brother?
I know, because it's so ridiculous to think.
I can't. What do I do with this? What am I supposed to do with this, folks? I can't. Donny articulates a very basic, well understood principle in population genetics, something that undergraduates just learning about the concept can understand. And just the first thing Matt says is ridiculous.
I think that there were, if you look in the evolutionary idea that you go back 200,000 years ago, there were probably 10,000 to 20,000 women alive at the time. Let's just go with the lower model. That means 9,999 of them left no proof of their existence in the genome at all.
Wrong. They left no proof of their existence in the mitochondrial genome, but the rest of the human genome, the nuclear genome, still has descendants from the rest of that population, because the rest of the genome has other most recent common ancestors in the more distant past. I don't know why this is. I mean, I know why it's hard. It's not hard. They're just like motivated reasoning, right? That's what's going on here. But like, it's just, I shouldn't be surprised, but I'm always surprised.
But yet there they were, dispersed around the world, and yet all of them died. They didn't leave any examples of anything. And that's why I always like to show that no matter what you do, you can't just look at one thing. You go and you look at when mutations started to rise up. It's all at the same time. When you look at genealogies, they go back at the same time. When you look at helium diffusion rates,
all right, so at this point, they get off on like a bunch of other topics. They start talking about like endogenous retroviruses. They start, they repeat themselves, talking about bottlenecks again. We already mentioned that earlier, so we're not going to cover that again. But the thing I just want to say before we move on, because there's another big jump here in time in the video, is that they're doing the misunderstanding the most recent common ancestor thing again, right? They're just doing the same thing. They think a most recent common ancestor is, there's one person at this point and that's it. That's not what it means. I don't have to repeat it again, but they're just doing the exact thing that I pointed out in my original video. So let's jump ahead now. We're going to jump again. It's a big jump up to, we're going to go to about 232 here. So we just skip all this stuff, go right up here. Okay. We can go one step further. Go just a little. Well, that'll do. Okay. So we're going to watch, this is kind of a big chunk. We'll pluck out a bunch of parts here. We'll do this for about 3 minutes. We'll pull out different parts over the next 3 minutes here. Okay, everybody? Here we go.
Differences, it fits biblical time. But then he goes and says the substitution rate is by definition going to be slower than the observed rate. Well, wait a minute. We understand, maybe I should go over some slides here. We understand that the per generation rate, and I wrote a technical article on this with Chris Roop.
Can we just appreciate that he thinks he wrote a scientific paper with Christopher Roop? It's kind of adorable.
The per generation rate equals the fixation rate. Notice this. Since on average it will take 4 NE generations for such mutations to reach fixation, about the same number of neutral mutations should be fixed every generation. The rate of fixation of mutations is theoretically constant and equals the neutral mutation rate. Matt, is this not saying that the neutral mutation rate equals the fixation rate?
Exactly what it's saying. Multiple studies say it.
Now notice this though.
I see if in the chat, see if you can spot the problem here. The neutral mutation rate equals the fixation rate. See if you all in the chat, see if I've done my job well, if you can spot the problem here before I point it out. Let's play that game. Let's see if we can do that. Again, what he just said as like the slam dunk thing was the neutral mutation rate equals the fixation rate. Don't let me down, folks.
So what their rescue device is, Matt, and I'm screen sharing, so I can't see, but I can predict if Mr. Anderson, since I debated him on this, if he's in the chat, they would say the per generation rate as mutations are lost through selection becomes the neutral mutation rate. The neutral mutation rate is slower than the per generation rate and equals the substitution rate. They're trying, Matt, and I know you know this, you know where I'm going. What Dan and these guys are trying to do is make the no selection zone, that box, as small as possible. They're trying to.
That is not what we're doing. That is not my argument at all. He just doesn't understand here. And again, pretty basic population genetics here is that any purifying selection is going to cause the mutation rate, the rate at which mutations occur, to differ from the rate at which mutations accumulate in that population. Purifying selection will cause that. And there's a bunch of reasons for this, and there's like lots of math you can do for this. We're not going to do any math here. But like, he's just saying neutral, therefore, mutation rate equals fixation rate. That's not how that works, because as some of you in the chat got, not all mutations are neutral, folks. There's selection happening. And here's the thing, like me, Donny, Matt, like we agree that natural selection is a thing that occurs. We agree on that. And then what happens when natural selection happens is, like, for example, let's go all out, right? Hard selection, death, right? You have a mutation that occurs and the individual with that mutation dies. That mutation is not in the population anymore, right? Okay, what about all the mutations that were linked with that lethal mutation? What happened to those? Well, if they were unique to that individual, they're now no longer in that population either, even if they were neutral. So if you have purifying selection, you don't have your mutation rate equal your substitution rate, okay? Like, this is not a super complicated concept. And I think what Donny is doing here we'll get more evidence of this later on in the video, is I think he is doing this on purpose. Like, he is conflating these two things that he knows is different. I'm based on what he says later, I'm quite confident in that, and we'll talk about it, as we go. Let's continue.
Make it as tiny as possible. But if a lot of these mutations are subject to natural selection, that contradicts the molecular clock that they so wholeheartedly want to believe in. The point is, you can't have massive amounts of selection. And so they want to ignore all the genetic noise, all the environmental noise, and shrink that no selection box. When in fact, when you consider degrees of noise, when you consider reality, when you consider the fact that the majority of the genome is functional and active to some extent, not just 10%, the no selection zone is huge. And so your per generation.
Can we just pause and appreciate that little bit of cognitive dissonance for a moment right there? Because that takes skill, folks. What he just said is that the fact that the majority of the genome is functional and active to some extent means that the no selection zone is huge, meaning most mutations are not subject to selection. So most of the genome is functional, right? At the sequence level, the nucleotides matter, but also most mutations are neutral. You can't be selected against. I don't know how those two things are reconcilable, but like, okay, that's what we're going. I think it's just ideas smushed together in Donnie's head. I don't actually know like how to make sense of those two things together. Let us continue.
Mutation rate is basically the neutral mutation rate because the majority of mutations are neutral. Notice this.
Majority of mutations, basically the mutation rate. You all hear the weasel words in there, right? Is all this little bit of hedging, but he's just, don't pay attention to that nuance. Mutation rate equals substitution rate, the end. But he knows. You can tell by what he's saying. He knows that they're not the same.
Right here. The great majority of those mutations that are fixed are effectively neutral with respect to fitness and are fixed by genetic drift.
Sure.
Tons of papers here. The vast majority of mutations are deleterious.
Which is it, Donnie? Are they neutral or are they deleterious? Because deleterious means hurts your fitness, which by definition, if it impacts your fitness, right, your reproductive output, then it's not neutral, right? That's what that word means. Now, there's a threshold for that, right, based on effective population size, where below a certain level of fitness effect, it's effectively neutral. But if a mutation is deleterious, in other words, if it is above that threshold, if it affects your fitness, by definition, it is not neutral. I don't know how many times I've said this. I don't know.
It seems unlikely that any mutation is truly neutral in the sense that it has no effect on fitness. And so the majority of mutations, brother, are nearly neutral. They're not subject to selection. Selection can't see them. They want to imagine, hope, dream, and imagine that Dan Cardinal is related to a pine tree, okay? They want to hope, dream, and imagine.
I don't know why they always go to that example, but it's like, oh, what's the common ancestor? It was a unicellular eukaryote. Like, it's not that hard. We know that one, guys.
Imagine that this no selection box is really small. And so most mutations are still subject to selection when that's not true. That doesn't fit reality. Your no selection zone, that box is large. And so your per generation rate for the most part equals your fixation rate.
How much work is the for the most part doing in that sentence, right? Because the phrase for the most part means not 100% of the time, which means the mutation rate does not equal the fixation rate. Like, he just said exactly the thing that I've been saying. I don't know if he realizes that that's what he just did, but that's what he just said. Right. I also want to point out at this point that they are, in theory, responding to that video that I put out last week. But like, what are they going to talk about anything that I talked about? They're just doing their normal pedigree mutation rate script thing here. And I've said for a while, I think Donny is auditioning to be the next Kent, right down to the mile-long stack of slides and the script on every topic under the sun. So like, that's what he's doing. He's doing his, his mitochondrial Eve shtick without actually responding to the stuff that I said, which is why Donny and Matt keep making the errors that I pointed out in my video. So we're going to jump down just a little bit here. Jump down just a little bit, about 2 minutes. All right. Here we go.
The evolutionary community has humans existing. Let's say we took a pen, Matt. Just the tip of the pen is known human history. Isn't that right? The last 4,500 years.
Yep.
Historical records, all of these kinds of records, direct records, you could say. Humans only go back 4,500 years. But they want to extend humans back 200,000 years out of Africa. So that means the majority of human history, humans existed what? In small populations, small tribes, isolated. And so you'd have faster rates of fixation for most of human history. Today, fixation is basically non-existent. It's slow. You're not going to get population-wide fixation in a population of 7 billion people. But this is just the tip of that pen. And so there is what's called...
Okay. So just a quick little thing I want to point out here is that Donny has once again contradicted himself, because like the central argument that not just these two, but like what all creationists argue fundamentally here is that the single generation per generation mutation rate is equal to the long-term fixation rate. Now, the single generation per generation mutation rate, that is a product of biochemical processes. Right? What's the error rate in DNA polymerase? What is the rate at which those errors are corrected? What is the rate of spontaneous, like, chemical breakdown of things like cytosine, which is actually pretty fast? And at what rate are those errors corrected, right? Those are the different factors that set your actual mutation rate. Those factors are all independent of population parameters. Okay, those are about things like enzyme kinetics. Okay, it's biochemistry. But then he's talking about how, population size in the past versus population size now, and blah, 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 blah. If he is correct, if creationists writ large are correct, that it's really all about that just kind of baseline, the correct measure. Just a little bit of background on this. When creationists do this, one mutation every X generations. When I say like that math is wrong, what I mean is the correct way to do this, the correct units for mutation rate, are mutations per site per replication. So like every time a base is replicated in the DNA, what is the likelihood that it mutates, right? It's mutations per site per replication. And then for substitution rate, the units are substitutions per site per year. And the reason we say per year is to normalize for generation time. So you can compare across organisms with different generation times. Now, all those intricacies there get lost, right? When creationists do this, they just do X number per generation. And what happens when you do that is you leave out the fact that one side of that equation, right, the mutation rate side, is fundamentally a biochemical process. And the other side, the substitution side, is a population genetics question. And by conflating those two things, Donny is completely missing that and undermining his own point, right? Because he's saying what we just listened to him say was, you got to look at the population dynamics of these small groups. So you get a lot of drift, high fixation rate, right? Whatever. If it's equal to the mutation rate, why does all that stuff matter, Donny? Right? Like, we already established that you agree that natural selection is a thing because you said it's not 100%. Okay. So now we can't just say one equals the other and you could, cross out your variables like you want to do. You can't do that. So now we're falling back on the fact that this biochemical process is basically dictating the rate of this population genetics process across populations that vary in important parameters like effective population size. It's completely nonsensical when you dig into the details of what he's saying. And what creationists like Donny and Matt count on is their audience, whether it's going to be a young Earth audience that is predisposed to just take whatever they're saying at face value, or in, you know, like a debate context, when the person they're debating is not an expert in this thing, they're just going to throw it out there and people are going to take it at face value. But you really do need to understand the, you know, what's going on under the hood here to see what exactly all the little problems are. And once you start pulling at these little threads, I hope everybody here that's watching can see just how quickly this falls apart. It's just a house of cards. It's complete gibberish that they're saying, and, you know, self-contradictory in a million different ways. All right, so we're going to do one more big jump here. He like starts doing the genetic entropy, like rust on a car thing. We don't need to watch that. That's not the point. That's not the point of any of this. So we're going to jump down. Let's see. So we're going to jump to almost an hour. That we're at like 2:37 right now. We're going to jump to 3:33. So like I said, folks, there's a lot of stuff that's not relevant here. So we're going to jump to 3:33. Yeah, they do like the vehicles thing. Yeah. All right, so let's go to 3:33. I promise we're almost done, folks. Hanging in there. While I'm scrolling, I'll take this opportunity to thank all of you for being here. I see about 80 people here right now. That is fantastic and makes me very happy. Thank you. Okay, so let us play this because they are going to go back to my video. And I'm just going to let this play for like, let's see, 33, like a minute or so, a minute and a half, and we'll talk about it.
Manifest in novel phenotypes. That's not manifesting in true anatomical change or addition in phenotypic complexity. It's based on morphological variability that's built in. A lot of what we see in terms of the variation is just based on created diversity, which I know our critics love. And I know
I just want to say the created heterozygosity thing, not the topic, not going to mention it, but I love how it's just like, we're going to do that too, just hitting every wrong thing we could possibly hit.
I'm going to say something, but I do want to address this real quick before I forget. If they're only strictly neutral, so basically this whole idea of mutation rate equaling fixation rate only applies to strictly neutrals. But again,
no, that's not what I said. He said that thing, mutation rate equals substitution rate, only applies to strictly neutrals. No, it only applies if there are only strictly neutral mutations occurring. And that's not the same thing, right? Because what he wants to do is say, okay, you have your mutations and some subset of them are neutral. Those are going to accumulate at, you know, the rate of at the mutation rate. But then you have your non-neutral, your selectable mutations. Those are different. We can discount those. But no, it's all occurring in the same genome, like we said before, right? If you have selection removing, you know, purifying selection operating on this, then that's going to affect the rate of accumulation for all the rest of these too, right? So what he just said, he couldn't even just read the words off the screen. He misinterpreted the thing that I said to mean something else, and that something else is incorrect. It's a subtle difference, but it's an important one.
As I pointed out earlier, when we were responding to Dan's video, the majority of mutations, and I went through a few quotes, are neutral, but very few of them being strictly neutral, nearly neutral. And the evolution is going to have to argue that the majority of the genome is basically neutral junk, 10%.
It is. A recent book on that by Dr. Larry Moran. It's yes.
Functionality. I know Dr. Dan doesn't mind arguing for that. I do appreciate the critics because it helps us strengthen our model. It helps us look into these issues. But the reason why basically the majority of your mutations are unselectable, and so your per gen rate, Matt, is basically your neutral mutation rate, is because the evolutionary community, they disregard a lot of noise. They disregard selection interference. They disregard a lot of biological noise. And so rather than...
I also want to point out that there is like a reasonable answer here, and they're not doing it because they don't know anything about this. But the reasonable answer here is to say we're looking at, it doesn't really work for mitochondria because they're haploid and non-recombining. But for the rest of the genome, the reasonable answer here is to say there's not much linkage because of sexual recombination. And that decouples the selectable from the non-selectable mutations. But like, he doesn't know that.
And look to biological realism. Okay. They want to oversimplify the math, oversimplify what we're dealing with here. And I don't think they realize it, but what it actually does is it it downplays the molecular clock that they want to believe in, that they essentially require. And so due to noise, biological noise, environmental noise, due to genome-wide activity, there exists a no selection zone that's really big. But they
once again, can someone like explain this to him in a way that will like help him understand it? Because that's not the argument, right? It's amazing to me that Donny can do this for as many years as he has been doing it. I don't know how long he's been doing this. I kind of met Donny in 2020 when I kind of stumbled upon the YouTube, Yekosphere. I don't know how long he's been doing this, but it's longer than 4 years, and he's been saying the same stuff for that whole time, and I just don't understand why he cannot understand it. Like, selectable mutations occur. They exist. Selection happens. We all agree on that, and that's it. It's not about like, oh, the no selection zone. Yeah, like sure, at the margins, the ratios matter. Like your distribution of fitness effects matters on the margins for what the rates will be. But in terms of will these two numbers be equal or not, that exact ratio, it's not the key thing here, right? That no selection zone in the distribution of fitness effects, that the size of that is not the key parameter we're dealing with here. It's, are there selectable mutations? Yes or no? And what's happening is creationists have bought the party line. They're high on their own supply. This one comes from John Sanford, where he misrepresents Kimura's distribution from 79, where Kimura said there are no beneficials, and he explained why he didn't include beneficials in his model. And then Sanford takes that and says, well, he thinks there's no beneficials. And then, people like Donny run with that and say the no selection zone is like the whole thing, which is not actually the case, especially because we have empirical distributions of fitness effects that actually have lots of selectable mutations, right? It's actually not that hard. But try to get that across to creationists and you will fail every time.
You want to make that no selection zone as small as possible and try and say, well, it only applies to strictly neutral mutations, because nearly neutral mutations, that group, the very slightly deleterious ones, they're eventually going to make a switch from drift to selection.
I don't know where he gets this from. That is not the argument. I don't know. Again, I don't know how he can do this for so long and not actually understand the arguments that he thinks he is responding to. Also, this has nothing to do with the video of mine that they're supposedly responding to. Like, I don't know what they're addressing here. He's just doing his script on this. But like the idea that the mutations that they're very slightly deleterious, but they're below the selection threshold, and then they're going to switch. Like, I don't know where he gets that. I genuinely, I don't, that's not relevant to what we're talking about here. I just don't know. You all, there's only like one sentence left here in this bit, and you all are going to love it. I promise.
But again, that hasn't been demonstrated mathematically. That hasn't been demonstrated in the biological world.
That's like very famously, like tide comes in, tide comes out. You can't explain that. Hasn't been demonstrated mathematically or in the biological world. There's like a century of like very well developed theory in the field of population genetics, mathematically describing all of these things, that has been corroborated with direct real world and experimental observations. Like, I don't know, like multi-generational pedigrees are direct observations. I don't know what he's talking about here. This is just, head in the sand, fingers in the ears, la, la, la. I can't hear you. I don't know what else to make of this. I got nothing. So let's jump down here. We're going to jump a few minutes. And we only have a couple of segments left that I'm going to play for y'all. Let's see. We are up to 3 hours and 35 minutes here. So we are going to jump down to 3:39, and then I'm going to play kind of a longer kind of bit here. Normally, I don't like to just like, let me just show things that I disagree with and just like rebroadcast them to the world. But I'm going to do that here because I think it's valuable for everybody to like see the degree to which RawMatt just has, I think, no idea like what coherent kind of point he's trying to make as he puts these sentences together. So we're going to go down to, we're going to just jump ahead just a few minutes here to, let's see, we're going to go, here we go. We're going to go right here. We're going to see how this goes. All right. Just enjoy, everybody.
Published in the population every 6 generations. Matt, did you want to, because again, I do appreciate Dan's engagement in his video as we start to wind down, because I know we wanted to end it at the 4-hour mark, but we've had a great audience the entire night. Did you want to briefly explain why? I'll share screen since we do have Dan's video here. Okay. I'm not going to play it like we did earlier, but over right around here. Do you want to explain his error in thinking on this issue? Where he says, if you were to take your rate here, mutation rate, you'd get 40,000 years. Can you briefly reiterate the errors of this point and slide, Matt?
Sure. That would be, we have to look, substitution rate is based on populations. So when you're doing a substitution.
Okay, so 2 things. 1, he doesn't know how to answer this question because he doesn't understand the claim I'm making. And 2, substitution rate is based on, he says, populations, effective population size, but like, okay, like, you get partial credit for that one, right? But like, he doesn't, so let's just watch him try. I just want to show this to everybody because this is representative.
Substitution rate, for example, like Parsons, he's going, okay, we're looking at the population today and we're seeing.
If we had a bingo card, Parsons would be on it and we would have just hit it right there.
Vast amounts of different populations giving different substitutions. He went right down the middle and gave one for about 1 every 30 to 33 generations, one in 1997, one in 1998. He found some populations had 1 substitution every 17 generations. He found others, like the Amish, had 1 every 80. So if you have different populations getting a new substitution, reaching fixation after a certain amount of generations, therefore, when Parsons ran the math, he goes, okay, we're about 6,500 by narrowing it, by rounding it all down. Does that mean that all populations are going to be getting it at that rate? No. For example, if the Africans who lived in Africa had small populations, and because they don't have farming there, and they lived in that region and it maybe had more generations.
I just want to point out the fact that RawMatt thinks they didn't have farming in Africa. There's some segments of young Earth creationism that like kind of go out of their way to be like races are not real and blah, 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 which is accurate. And like it's literally the only thing I can give Answers in Genesis credit for, right? They lean hard into the races are not real thing, which like literally the only thing I can say, good job, Ken Ham, right? Matt, on the other hand, is leaning into a different young Earth tradition, let's say, that posits there are actual differences in different people groups around the world in terms of things like mutation rate and also like culturally, where he like seems to think that certain groups didn't have agriculture, which, oh dear, oh my.
They're going to accrue more mutations because they're having more generations, and then smaller populations having fixation reaching higher. That's why Africans look older than anybody else. Other places in the world, once you start to get up to Egypt and move north, east, you get people that do farming, agriculture, much, much more. So it gets a larger population size. So you get larger populations, harder for a mutation to go up through the general population and reach fixation. So of course, when you're studying them today, we're just going to take the general number and be like, okay, this pedigree study shows that we can account for these mutations in a population. If we look and just round off, we can still explain the diversity in the mutation rate and the substitution rate, explaining the diversity in the young Earth creation timeline in multiple.
So I just wonder, do you think like that eats away at Donnie's soul a little bit every time he has to listen to something like that? What do you think? I think it probably does. Because I think he's listening to that, and I think he knows just enough to think like, what are you talking about? I would like to think that. Maybe I'm not sufficiently cynical, but that's what I think. I don't know what RawMatt is talking about here. I mean, he literally thinks there was an agriculture in Africa. Like, does I know like we'll say like pre-medieval or pre-colonial African history is not typically taught in, the West. Um but like man, Africa had like sub-Saharan Africa, which is what he's talking about, because that's why he distinguishes with Egypt and Africa, as though Egypt isn't in Africa. But like sub-Saharan Africa had like very sophisticated political systems, agricultural systems. You've got like very sophisticated like irrigation systems, vast trade networks spanning across the continent. Like, I don't know what he thinks. Like, it's just astonishing to me. I again, maybe I shouldn't be surprised. I should stop being surprised. Yeah. That's all. That was the purpose of that. I just had to pluck out like, just here it is, everybody. Here's Matt given time to just like for 3 minutes, just go, and that's the mush we get out. All right, so let's jump down to just jump a couple minutes here to about 3:44.5. Here we go. Let's do this. Now, here's this little bit is related to the thing that I ended my video with. So again, if you're watching this and you haven't watched the original video, this little bit is just the last couple of minutes where I screen grabbed a YouTube comment that RawMatt made. And that's what I'm talking about here. So let's just let Donnie introduce this here.
Because, it could have been only 400 years. It could have been 1,100 years. The debate continues on it. Depends on the model.
All right. Well, you know what? Your best bud, Dan, he's coming at you. So let's pretend you're debating him right now, and I'll pretend to be Dan. But Matt, this just means you lump together a bunch of studies that you shouldn't have. And so my math wouldn't accurately represent the point you made. What are your thoughts?
Okay. So I want to make clear the point of this comment, because these two did not get the point. What I'm responding to is RawMatt pooling a bunch of studies and saying that gets you a mutation rate of 1 mutation every 33 generations. And I did math with that. And you draw that out, 1 mutation every 33 generations, and you get like 39,000 years, which is obviously outside of the young Earth timeline for the mitochondrial most recent common ancestor. Like, obviously, clearly outside of that timeline. Now, I'm like trying to help Matt here. What I'm doing with this comment is giving him an out, because he could cop to a minor error that gets him out of the major error that he actually made. So what I'm saying here is, it looks like what you're doing is you're taking a bunch of studies, some of which are whole genome mitochondria, and some of which are just looking at, the hypervariable region or the D loop or the control region. You're just looking at those regions, but then you're kind of taking that, whatever number that is for that relatively small number of base pairs, and you're saying that number applies to the entire genome, which is going to change your rate, right, when you pool them. I'm saying he's making this apples to oranges comparison, and that's not valid. If he just says, oh yeah, I lump these things together, then that's it. You just fix your math and go about your day, right? All he has to say is, I took the raw numbers, whether it's full genome or not, which is, it's not valid, but it negates the argument that I'm making. So all he has to do here is cop to this very simple error that doesn't have a broader implication for his argument. That's all he has to do, and I'm giving him the out to do that. Let's see if he takes that out.
Why would we not look at other studies? Some studies are, we're trying to show from our model that multiple pedigree studies give the same result, whether or not they're looking at the entire mitochondria, whether or not they're looking at the D loop region, whether.
Okay, so he's not going to take the out that I have given him. He is going to double down. That's what's happening here. He's just doubling down on the thing that I said he did. He is just straight up like, yep, that's what I did. And we're just going to go with those numbers and just claim that they show something that they don't show because I did the math on screen. And he's saying, no, you actually get 6,000 years.
Whether or not they're looking at a single hypervariable region, they're getting the same results. That's what we're talking about here. Deep rooted, shallow rooted, multiple families, one family. So the fact that multiple studies are giving the exact same result, and then the critics are saying, oh no, this isn't good, it just goes to show you of how devastating that actually is for evolution. You need 200,000 years or more. I think the net bottleneck's now like 314,000. So you even need.
Again, he's still doing the most recent common ancestry equals bottleneck thing. By the way, this is the last segment we're going to do before I wrap this up. I know we've been going for over an hour and a half. Thank you for bearing with me, everybody. We're almost done.
More time. And so we're getting less, and you don't need less. You guys need more time. So that's why, what was this? So you would look at this and say, okay, if we go back 6 generations and we had 60 mutations, which is 120 differences, 360 generations, not very good for evolution, but you go, well, that's not exactly 7,200 years. Well, that can actually be answered by looking at another one. You can go ahead and look at the Greek.
He just keeps digging. I already gave him an out on the 7,200 years thing. I already said, like, that's close enough to 6,000. Call it good. And he's like, no, we go to this other chronology, blah, 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 blah. Like, Matt, you don't have to do that. He can't help himself.
Septuagint, if you don't want to believe in the Masoretic text, which is the most popular Bible, which goes to the King James Version. And the Masoretic text has the creation event 5,540 BC, which places it about 7,560 years ago. So actually there is plenty of time when we look at, if you want to use the mutation rate just for that aspect alone, then that rounded on 7,200. You can actually put a generation time to like 21, 22 years and still have plenty of time. But our goal is to answer the genetic diversity through mutation rates, and we can in our model.
This is like the third time he said this exact phrase. Our goal is to explain the existing diversity according to the mutation rates, blah, blah, blah. Like, he has said that exact sentence 3 times. It's just like one of those things in his head. And when he doesn't know what to say, he just like glitches to that thing.
And that's really all we need to do. And since we can point to that, and you guys have to say, no, there's other examples and there's reasons why it's not true. Sure, you can believe that all you want. That's fine. But we're pointing at the actual evidence.
All right. That is where we're going to call it. Because he's ending is perfectly fitting to end there. We creationists are pointing to the actual evidence, and you evolutionists are not. Because remember, the thing that I pointed out in the video that they're responding to is that they are cherry picking data. They're picking the studies that they like and they're ignoring the ones they don't like. And here he's saying, oh, we're pointing to the real evidence, but you're not. Explain the studies that I pointed out that are directly observed pedigrees that indicate a slower rate of mutation accumulation than would be compatible with the young Earth timeline. They don't even want to talk about them. That's the thing that's going on here. It's like they watched my video and then decided, yes, let's do each of those errors. That's what's happening here. So I want to just, as we wrap this up, I'm going to take the video down now because we could be done with that. So as we wrap this up, I want to just call your attention back to what we talked about at the beginning, right? I said there were, in my video that they're responding to, in theory, there were a bunch of problems that I raised, right? And I said, let's see if they actually respond to these issues, right? The misunderstanding of the most recent common ancestor concept. They just repeated those problems over and over again, thinking it represents a bottleneck, thinking it represents the only person alive, scoffing at the basic population genetics of the concept. The mutation versus substitution rate conflation, constantly doing that throughout this video. Even though they're describing situations where they would be decoupled from each other, they're still saying, of course, they're equal. Didn't bring up autosomes at all. The fact that autosomes are going to converge at a more distant point in the past. Didn't do that. Didn't mention at all the direct confirmations of the phylogenetic mutation rates using like documented migration events in historical timeframes. Then we could compare those different populations to each other. Ignored that one. Coding versus non-coding DNA, mentioned the hypervariable region, didn't realize why it's a problem. Doing the math, just doing the math the same old way, just not even caring to try to do the math correctly. And then, of course, we saw throughout this video that they continue to just cherry pick their studies, right? Obviously, they really passionately love that Parsons paper. Don't care too much for the deeper pedigrees, the full generation studies that give a different answer. Before we close the book on this one, there's one more thing I want to point out here. And it's that this was like bad and incompetent, but it wasn't like so bad by young Earth standards. Like if you take any random young Earth creationist, this is what you're going to get, right? Somebody like Dr. Rob Carter would not have done much better doing this response. It would have been cleaner, it would have been clearer, it would have been mercifully shorter, but he wouldn't be making arguments that are better than what Donny and RawMatt did here. Part of that is because these two are just, they're just paraphrasing the professionals, right? They're not developing their own arguments. They don't have like original ideas. So part of it is like this game of telephone where you take the professional argument and then it kind of goes through the blender here and it comes out as what we just watched. But another part of that is like there just genuinely aren't good arguments on the young Earth creationist side. So like you're going to get what you're going to get, right? And it can be packaged better or worse, but fundamentally it's going to be pretty comparable. The big takeaway is, as always, with what we do here on Creation Myths, is that I want to provide you all, the audience, with the tools to deal with these claims when you encounter them in the wild, right? You can watch my original video on this topic. You can subject yourself to the Standing for Truth video on this topic. And you can see how I respond to their response to my arguments, right? Their attempted rebuttals. So that is where we are going to leave this for tonight. I want to thank all of you for being here. I still see like 80 people here. So I appreciate you all spending this much time with me this evening. I hope you enjoyed that. I hope you found it entertaining. I hope you found it educational. And I hope you are able to put into practice some of the stuff that we talked about tonight, if and when you encounter this stuff in the wild. So please hit the like button before you leave, share this video. If you're here, if you're watching and you're not subscribed, please subscribe. I would appreciate that. That would be great. And just a reminder, we got another live show next week with Dr. Zach Hancock and Mr. Anderson. It's going to be great. Plus, at some point soon, I'll have a really fun announcement for everybody. So excited. Can't wait. But that's where we are going to call it tonight. So thank you all again for watching. I appreciate it, everybody. Have a great night and don't get fooled. And now we're going to hit end stream. Good night, everyone.